theorem. If we divide (72 by 3), any number by its factor, now in this case, if 72 is divisible by 3, then remainder is equal to 0. Why remainder is 0? Because 72 is exactly divisible by 3. Or in other words, you can say that 3 is a factor of 72. So if 3 is a factor of 72, then remainder will come out to be 0. Same is the case here. If we deal with, when we deal with the polynomials, I have considered an example. Show that x minus 2 is a factor of x cube plus 2x square minus 11x plus 6. If x minus 2 is a factor of this polynomial, then remainder will be 0. So to show that x minus 2 is a factor of this polynomial, we have two different ways. So first, the basic technique is the division. I'm going to divide the polynomial by x minus 2. Yesterday I told you the technique. The first of all, you have to arrange the polynomial in descending order. The divisor should also be in descending order. First term of the dividend divided by the first term of divisor to get first term of the quotient. Quotient multiplied by the divisor gives you x cube minus 2x square. Changing sign to subtract them. Again dividing 4x square with x, we get plus 4x. Now this 4x multiplied by x minus 2 gives you 4x square minus 8x. (11x plus 8x gives you minus 3x. Minus 3x divided by the first term. So I have divided minus 3x by x, that gives you minus 3, and minus 3 multiplied by x and minus 2 gives you minus 3x and plus 6. So the remainder is 0. This division shows that x minus 2 is a factor of the polynomial x cube plus 2x square minus 11x plus 6. So if expression is a factor of the polynomial, then the remainder will be 0. Similarly, another technique that is called the factor theorem. I'm representing the given polynomial by px. To check whether x minus 2 is a factor of px, I have to replace x by 2. using this value. So replace x by 2 in the given polynomial. That is equal to 0. So it also proves that when we substitute 2 in place of x, the polynomials values come out to be 0. So this technique is called the factor theorem. So there are two ways. One is the basic technique. You divide the polynomial by the given factor. Because the remainder is 0, we can say that x minus 2 is a factor of the given polynomial. Or you just have to replace x by 2. We get 0. So it proves that x minus 2 is a factor of a given polynomial. Let's have another example. So using factor theorem, I have to replace x by 3 in the given polynomial. So it comes out to be 0. So which shows that x minus 3 is a factor of px. If we use division technique, dividing x cube by x, I get x square. So changing signs just to subtract. Again, dividing first term 5x square by x, I get 5x. Multiplying 5x with x minus 3. Again, the remainder is 0. So which proves that x minus 3 is the factor of the given polynomial x cube plus 2x square minus 16x plus 3. So the rule says if x minus a is a factor if x minus a is a factor of a polynomial px, then pa will be 0. It means you have to replace x by a. Like if I'm dividing the given polynomial by x minus 3, so I have replaced x by 3. So this is your factor theorem. Well, in this question, it is given that x plus 4 is a factor. If x plus 4 is a factor of px, it means if I replace fx by minus 4 in the polynomial, the remainder comes out to be 0. So it is given, in this case, we don't have to prove, it is given that p minus 4 is equal to 0. So replace x by minus 4 in this polynomial. In the previous case, we had to show that it's a factor. Now it is given x plus 4 is a factor of polynomial. You have to find a. So I have used x plus 4 is equal to 0. That gives me x is equal to minus 4. The value of x is equal to minus 4, I have to replace in the polynomial to find. And I know because x plus 4 is a factor, so it comes out to be 0. This equation is given this time. So x cube plus so that's what I mean. That the polynomial, after substituting this value, I know the answer will be 0. Because x plus 2 is factor. If x minus is a factor, then PA is 0. So it is already known to me. So using this technique, I will find the unknown A. So value of A is minus 4. So I hope you understand the technique which we are going to use in this exercise. So if you have to prove that the given expression is the factor, you have to replace x by a in the polynomial and the answer will be 0. If answer is 0, then it is a factor. But if it is given that the expression is a factor, x plus 4 is a factor, then it means the after replacing the value in the polynomial, you will get 0. It is known this time. To prove the factor, you have to prove it is 0. But if it is given that is a factor, then it means answer will be 0. So using this technique, you have to find the value of a. Last time I gave you exercise and I'm quite sure that you people have done it. If you have any problem in it, again, I'm telling you, you can ask me the question, but you must practice the basic technique of division. In some cases, you have to use that technique. So you have to perfect it because the procedures are lengthy. Because of the lengthy procedure, there are more chances of making mistake. So there is only one way to avoid the mistake is to practice lot of questions. Let's have another example. Now it is given that 3x squared plus 5x minus 2 is a factor of the given polynomial. To find the values of a and b, if I use a division technique in this case, I cannot find a and b together in by that technique. Now, because there are two values, so I need two equations for that. So for that purpose, I am going to factorize it. You have to use the basic technique of factorization. The product of 3 and 2 is 6. So two factors of 6. Factors of 6 that gives you 5 are 2 and 3. So I need 2 and 3 to get positive 5. But the product is negative, so I have to use negative. Sorry. It will be positive 6 and negative 1. So 3x squared plus 6x minus x minus 2. That gives you now these are the two factors of 3x square plus 5x minus 2. Using these factors, I will find values of a and b. Because these are the factors of 3x square plus 5x minus 2, they must be dividing the given polynomial as well. I'm using 3x minus 1 is equal to 0. That gives x is equal to 1 by 3. So P 1 by 3 is equal to it will be 1 by 9, 17 by 9, a by 3 plus b. And it is equal to 0 because 3x minus 1 is a factor of the given polynomial. So we get a 1 plus 17 plus a plus 3b is equal to 0. So a plus 3b is equal to minus 18. That is one equation. Similarly, I'll use other value as b is equal to, let's take 17 . It is similarly using x plus 2 is equal to 0, x is equal to minus 2, I get p minus 2 is equal to 3 into minus 2 cube plus 17 into minus 2 plus a into minus 2 plus b is equal to 0. So these equations come out to be now using these two equations and solving them simultaneously, we can find the values of a and b. How to solve them simultaneously? You people are quite familiar with that. I'm not going to go into that detail, but the technique that I have used is I have factorized the quadratic factor because the given factor is quadratic, so I have to factorize it. These two factors are still the factors of px. So I have used these two factors to get two equations in terms of a and b, and then using them, solving them simultaneously, we can obtain the values of a and b. I'm going to send you an exercise, and in that exercise, similar question will be asked, and you have to practice at home, and you can ask me again. I'm telling you again and again, you must try these questions. Don't wait for the later time. Do it now. You have ample time to practice them, and we are doing these questions very slowly. I'm not going very fast. So you have time, you must do it now and practice each and every question. You will find it very easy. And if you have any problem, you can call me anytime. I'll be there to help you people. That's all for today. Thank you very much.